types of factoring that we've seen. So the first thing you see on the screen here is the process for factoring. The first thing that you want to do when you factor is always to check for the greatest common factor to see if you can pull anything out of every term. Once you do that, check what's left over in the parentheses for any of the special cases we've looked at. If it's a binomial, check for difference of squares. If it's a trinomial and the lead coefficient is 1, use the T-chart method. If the lead coefficient is not 1, use the AC method. If what's left in the parentheses is a quadnomial, there are 4 terms, you can check for factor by grouping. The second piece we're going to look at today is the zero product property. What that says is if the product of 2 quantities is 0, one of the quantities must be equal to 0. So our example down here, if A times B equals 0, then either A equals 0 or B equals 0. They could both be equal to 0, but usually it's just one or the other. All right, so we're going to take a look at this combination factoring. So our first step is to look for the greatest common factor. Here we've got a greatest common factor of x. So we factor out the x cubed. When you pull 1x out, we have x squared left. X divided by x is 1. And what I notice inside the parentheses is a binomial, 2 terms, so I'm going to check for a difference of squares. X squared is a perfect square, and so is 1, so I can continue factoring. Remember, difference of squares, you take the square root of the first term, which is x, minus the square root of the second term, and then multiplied by the quantity where the second term is 1. So x times the quantity x minus 1 times the quantity x plus 1. So now we have that in fully factored form. Our second example, when I'm looking through, I see a greatest common factor of 2. So I'm going to factor out the 2. And what I have left is 2x squared minus 9x minus 5. This is a trinomial. The lead coefficient is not equal to 1, so I'm going to use that A times C method. A is 2 and C is negative 5. So we need something that multiplies to negative 10 and adds to negative 9. So we're going to take a look at some combinations. My first thought when I'm looking at multiplying to negative 10 is 2 times 5. One of those would need to be negative. So if I had 2 plus negative 5, that would not equal negative 9. So 1 times 10. And now we just need to figure out which one's negative. Since I need to add to a negative number, I'm going to check where the bigger number is negative. 1 plus negative 10 is negative 9, so those are my 2 terms that work. We have to keep that greatest common factor out front. We're just going to take a look at factoring what's inside those parentheses. So we rewrite that negative 9 squared as a positive 1x, or positive x, minus 10x. And the first and last terms are left alone, the 2x squared and the negative 5. So then we factor by grouping. This is going to get a little complicated keeping that 2 out front. So try and follow along. The 2 is just going to continue going out front, and actually I'm going to use brackets to keep track of the factor by grouping inside. So for my 2x squared plus x, I have a common factor of x, and what's left is 2x plus 1. My second 2 terms, I have a common factor of negative 5. What's inside my first set of parentheses is positive, so I want to pull that negative out of the second 2 terms, so that inside my parentheses is positive as well. So negative 10 divided by negative 5 is a positive 2x. Negative 5 divided by negative 5 is a positive 1. And then I pull this all together. My greatest common factor inside the brackets is 2x plus 1. And what's left for my first term is x. And I'll show you where I'm getting that from. So here's my x. And what's left for my second term is negative 5. So my complete factored form on this one is 2 times the quantity 2x plus 1 times the quantity x minus 5. Alright, so here I have a quadnomial, so I'm thinking I'll probably be doing some factoring by grouping, but before I start that, I always want to check for that greatest common factor. So what goes into 12 and 8 would be 4. Looking through, there isn't a common variable on any of the terms, so I can't pull out an x or a y. So when I divide everything by 4, I'm left with 3x squared minus 2xy plus 3x minus 2y. Okay. So then I'm going to take a look again at factoring by grouping. The 4 is just going to be out front, so I'll use brackets. My first two terms here, I notice that I have an x in common. So I'm going to factor out an x, and what's left is 3x minus 2y. On my second two terms, the signs are in the right order, positive, negative, so I'm going to pull out a positive 1. There is no greatest common factor in this case, but I do notice that that 3x minus 2y is what I have in parentheses from what's left over from my first two terms. So I do want that 3x minus 2y. And then we factor. So my common factor is 3x minus 2y. And then what's left over is x plus 1. On our last example of combination factoring, right away I noticed that greatest common factor of 3. So I'm left with x squared minus x minus 12. So what's left in the parentheses is a trinomial with a lead coefficient of 1, so I use that t-chart method. I need my answers, my two factors, to multiply to negative 12 and add to a negative 1. Multiplying to negative 12, the first things that jump out at me are 3 and 4. So to add to that negative 1, I would want the greater number to be negative. 3 plus negative 4 does equal negative 1. So I'm going to factor this into x plus 3, x minus 4. The last piece is solving equations using that zero product property. So the first thing we do is set the equation equal to 0 if it's not already equal to 0. Our first example, we have our equation equal to 0, so we factor. This is a difference of squares, so we've got x minus 8 times the quantity x plus 8 equals 0. Don't lose your equation. The zero product property says that either your first quantity is equal to 0, so I'm going to set x minus 8 equal to 0, or your second quantity is equal to 0, so I'm going to set x plus 8 equal to 0 as well, and solve each of these equations. So my first equation, I'll add 8 to both sides, and my second equation, I'll subtract 8 from both sides. So when you're looking at this quadratic equation, x squared minus 64 equals 0, either x could be positive 8, where you'd have 8 squared is 64 and minus 64 is 0, or x could be negative 8. So negative 8 squared is also positive 64, minus 64 is 0. Alright, so our next example, we have an equation where I see an x squared term, but it is not equal to 0. So my first goal on this one is adding 16 to both sides so that my quadratic equation is equal to 0. And I can use that zero product property. So this is a trinomial with a lead coefficient of 1. So I'm thinking what multiplies to 16 and adds to 17. My first thought when looking at 16 is 4 times 4, but 4 plus 4 is not 17, so then I'm thinking 1 and 16. So we're going to factor this as x plus 1, x plus 16 equals 0. And again, that zero product property, either the first quantity is 0, so I set x plus 1 equal to 0, or my second quantity is 0, so I set x plus 16 equal to 0, and solve each equation. Over here we subtract 1, and on our second equation we subtract 16. And finally, our last piece is writing equations given the zeros. So what we think about is the zeros of the function are the x-intercepts, or where y is equal to 0. What we do when we write the equation is we write it in vertex form, and we're putting it into the asylum. So if my 0 is positive 2, my graph crosses the x-axis at positive 2. When it goes inside the asylum, it's a negative 2. And my other 0 is negative 1, which means it goes inside the asylum as a positive 1. So here we have our quadratic function written in in factored form. To write it in standard form, we simply use distributive property. So we get our x times x is x squared, x times 1 is x, negative 2 times x is negative 2x, and negative 2 times 1 is negative 2. Combining those like terms, x minus 2x is negative x. And our second example, our zeros are 4 and 7. So when I substitute those into the asylum, I have x minus 4 times the quantity x plus 7. To put that in standard form, I'm going to go ahead and distribute. X times x is x squared. X times 7 is 7x. Negative 4 times x is negative 4x. And negative 4 times 7 is negative 28. Again, combining those like terms, I get x squared plus 3x minus 28. And that is today's lesson, and that is it for factoring. Next week, we're going to take a look at some graphing.